Hello everyone. Today shall discuss question number 2.12 of the chapter motion in a straight line. You see what is the question and solution. We are solving this question. You see in this way how you see. It is the first question. We are going to question number A. Now look at the graphs A to D, A, B, C, D. There are four graphs. Carefully and state with reasons which of these cannot possibly represent one-dimensional motion of a particle. In the first place, you see the given graph xt graph shown in figure A does not represent, this one does not represent one-dimensional figure. What is the reason? One-dimensional motion. Why? The reason is that this is because a particle cannot have two positions at the same instant of time. A particle cannot have two positions at the same instant. So this time, you can see here, at this time, at a particular instant, suppose this time I am taking, this time. In this time, there are two positions of a particle, this one and this one. It cannot be possible, right? This is x and this is also the same. So this is not possible for one-dimensional motion. This is wrong. So right. So you can write that the graph xt, that is the graph, that is the graph, that is the graph xt, the given graph xt does not represent one dimensional motion, one dimensional motion, one dimensional motion of the particle. What is the reason? This is because a particle, this is because a particle cannot have two positions, cannot have two positions, cannot have two positions at the same instant of time, at the same instant of time, same instant of time. Right? Now you go to the B section. You see this one is B. Here you can see also that the VT graph, velocity and time. You can see here this is positive and velocity is B. So the given VT graph does not represent one dimensional motion of the particle. This is because the particle can never have two values of velocity at the same instant of time. Here also you see at the same instant of time, suppose I am taking this time, I am taking this here as taking this time. In this time it has two velocity, one at this point, one is at this point. So it is not possible, right? So you can write here as this, that the graph, that is the graph shown, that is the given VT graph, the given VT graph shown in C, shown in B does not represent one dimensional motion, one dimensional motion of the particle, of the particle. This is because a particle can never have two values, two values of velocity, two values of velocity at the same instant of time, at the same instant of time, same instant of time. Number C. Number C, see this graph. You see here speed. Speed is, this is a positive case. You see here, if you see here that this is positive speed and this is negative speed. Since speed is scalar quantity, it cannot be positive and negative, right? So this is also doesn't it represent one dimensional motion, right? So the given VT graph is speed time graph. The given VT graph does not represent one dimensional motion, one dimensional motion of the particle. What is the reason of the particle? This is because speed is a scalar quantity, and it cannot be negative, right? And let us consider the fourth one. Fourth one is here what is given. Fourth one, you can see here the fourth one is given in this way, that the total path length. Here you can see that the graph is in this way, that is fourth one is given in this way, that this graph we are finding the path length. You see here we are finding the path length. This is positive, and here you see path length is decreasing here. It cannot be possible, right? Path length increase and then decreasing. No, but decreasing is not possible. So you can see here also, and you can write the answers in this way. You can see here, that is D, that the given VT graph, the given path length xt graph does not represent one dimensional motion, motion of the particle. What is the reason? Reason is that this is because the total path length traveled by the particle cannot decrease with time, So this is the case of 2.2.D. Thank you everybody for watching this video.